The first stop for every tire that enters a Bandag retreading plant is receiving. Here, a work order is created to follow each tire through the retread process. The tires are also barcoded for tracking purposes. Once a tire goes through receiving, it moves to Step 2, Initial Inspection. This is arguably the most important step in the retread process, as more than half of the failures of retreaded tires can be traced back to poor initial inspection. We begin the initial inspection of the tire with a thorough visual inspection. The 7-step process begins when the tire is placed on a mechanical spreader, which allows the inspector to see the inside of the tire more clearly. Then he examines the sidewall of the tire. Next, he moves to the inner liner and then to the bead area. After a thorough inspection of one side of the tire, he checks the other sidewall and bead area, as well as the other half of the inner liner. Then he moves to the crown area, the 7th and final step of the visual inspection. Notice how much the hands are used throughout the inspection process. It's important to both look and feel for foreign objects, such as rocks, nails, and screws. Anything that is found must be removed. Here, our inspector has found the nail hole in the casing. He'll denote the hole with a marking so that it can be repaired later in the retread process. Once the visual inspection is completed, it's time for the electrical inspection. During this important step, punctures or other injuries not visible to the naked eye are identified via an electric impulse. A spark pinpoints imperfections that can be repaired later in the process. If at any time during the inspection process a tire casing cannot be repaired and returned to safe service, it is rejected and taken out of the production line. Step 3 of the retread process is shearography. Shearography is a leading-edge technology that uses laser technology to optically dissect the tire casing as cameras capture images, and vacuum pressures are applied to the casing. The vacuum pressure provides stresses to separated components and is displayed using video. During this step, the casing is scanned from bead to bead so that flaws in any part of the casing can be detected. First, the operator loads the tire onto the shearography machine, marking a reference line at 12 o'clock. He then presses the start button and the machine automatically scans the tire. After going through receiving, initial inspection, and shearography, the tire is ready for Step 4, the buffer. The purpose of the buffer is to remove old tread rubber so that the surface is clean and smooth, perfect for Bandag's uncured material to adhere to. The buffer also trues up the tire casing. During this step of the retreading process, the operator loads the freshly inspected tire onto the buffer machine. Next, the tire is inflated to its optimal pressure, so it's in normal running condition. The casing is then buffed for uniformity by buffing to a predetermined crown width, radius, and symmetrical profile. The 5th step in the retreading process is skiving. During this step, the operator removes any steel cord material that has been damaged by things like rock, grills, and penetrations. He also removes any rusted steel cords. Skiving ensures such defects won't worsen, possibly resulting in a retread failure. First, the operator trims out the damaged or rusted area. Next, he trims back the steel cords to solid material and then removes any final damage. Once this is done, he uses a wire brush to do a final cleaning of the area. Lastly, cement is applied to prevent oxidation and provide a tacky surface for the uncured rubber to bond to. Step 6 in the retreading process is repair. It is during this step that injuries to the tire that remain post-skiving are addressed. Damages include larger injuries such as bead damage, crown injury, shoulder and sidewall injury, and sidewall splits. Bandag uses materials specifically designed for use with the Bandag process. In this way, repairs become a permanent part of the casing for long, dependable performance. First, the operator cleans the liner to prepare the area inside the tire for the repair. Next, he removes all of the damaged material, in this case, a puncture. He drills out the puncture from both sides to remove any damaged or rusted steel. Then he checks the inner liner to make sure that no further damage has been done. The inner line is cleaned one more time and then given the proper buff texture required for the repair to adhere to the line of the tire. The next step is the final preparation of the injury. Here it is chiseled down with a special stone and trimmed of all of its loose ends of steel. Finally, the proper rubber cement is applied to the liner. This material is used to provide tack to the interior surface and to begin the curing process for the repair that will be installed. First, the operator uses an extruder gun to fill the hole with uncured rubber that was created in cleaning out the injury. Next, he installs a repair in the rubber liner. Once installed, it is stitched down to ensure proper adhesion to the liner. The last step in the repair process, the operator prepares the outside of the repair, smoothing out any uncured rubber. During step 7 of the retread process, applying cushion. A thin layer of uncured rubber, called cushion gum, is applied to the buffed surface of the casing. It fills in any skivouts created earlier in the process and prepares the surface for the new tread to be applied. Once that rubber is cured in the curing chamber, it forms an unbreakable bond between the casing and the new tread. Step 8 of the retread process is building. In this step, a pre-cured tread is applied to the tire casing. When building, the Bandag builder automatically measures the tread to ensure it is applied to the casing and distributed evenly over the circumference of the tire. The ends of the tread are spliced together, and the splice is then temporarily stapled to hold it in place during curing. Finally, the tread is stitched to the casing to eliminate any trapped air. Step 9 of Bandag's retread process is enveloping. During this phase, the tire is encased in a flexible rubber envelope, which conforms to the shape of the tread and casing. This envelope causes uniform pressure to be applied to all tire surfaces during the curing process. Once the envelope is on, the tire is placed on an arc stand where rubber arc rings are installed to seal the envelope at the beads. At this point, the tire has an airtight seal. It is vacuum tested to ensure there are no holes or leaks in the envelope. During step 10, curing, the prepared tire is put into a curing chamber at a very specific temperature and pressure, and for a very specific amount of time. Here the uncured layer of cushion gum is cured, and the pre-cured tread is bonded to the tire casing. It's interesting to note that Bandag uses the lowest curing temperature in the industry, which is easiest on the customer's casing, and allows them to be retreaded multiple times. During the final phase of the retread process, the final inspection, the tire is inspected to ensure correct processes have been followed and that all customer requirements have been met. During final inspection, the tire is also entered into Bandag's proprietary system and painted with weather-resistant paint.